So ladies and gentlemen, welcome to our mathematics class. Welcome to our mathematics class, and in this class I am simply starting a new topic. And this topic is what we are just calling functions. So I'll start this topic, which will be one of the content for your test one for those who are doing natural science courses, like those who are doing engineering, actuarial science, and also other courses which are under the natural sciences. So I'll basically define what a function is, and I'll also show you how you can easily identify a function. So this simply means that this class will be a little bit short as compared to other classes. So like I've already stated, we'll look at functions. So I'll start with what a function is and what you need to expect when you talk about a function. So here are some of the things that you need to understand when you talk about a function. One, you need to understand that all functions are relations. All functions are relations. So this is the first point that you need to understand. All functions are relations. Okay. Then this also simply means that since all functions are relation, we need to understand what is the relationship between a function and a relation. Okay, so a relation is normally mapped on the input to the output. So you normally have the input and the output when you talk about the relation. So when you talk about the relation, you need to consider two things. You have the input. Okay, you have the input, and you have the output. You have the input and the output. So if you look at the relation is just something that is overall. It's more like a function is a subset of a relation. Okay, so like I've already stated, a relation has the input and the output. So let's say if this is our input and then we have our output there, and then let's say if I put an equation, which is, let's say you have y is equal to x plus 2. So this is a relation. Okay, this is a relation, the equation which is defining the relation. So if I was to put a 1 there, I put a 1 I replace there, it's going to be 1 plus 2. Okay, so I'm assuming that the input is x and the output is what? Is y. I'm assuming that the input is x and the output is what? Is y. So if I put a 1 there, this will simply be 3. If I put a 2 there, this will simply be 4. And if I put a 6 there, this will simply be what? This will simply be 8. So if you look at these two relations, this one is being mapped on that one, this one is being mapped on that one, and that one is also being mapped on that one. So this is a what? Is a relation. It's just showing the relationship between the input and the what? And the output. Now, when you talk of a function is a what? A function is simply a relation, and in a function has the input, which we call the domain, and the output, which we call the what? The range. So let me write what I've just simply stated. So a function is a relation. A function is a relation with an input, okay, with an input called the domain, and an output called a range. So a function is just a relation, like I've already stated. This simply means that a function is a subset of a relation. So a function is a relation with an input called a domain, and an output called a range. Then one thing you need to understand, that in a function the domain determines the range. So I need to write that and take note of it. It's very important. So a domain determines the range. In short, the range depends on on the domain. The range depends on on the domain, and this domain has a unique range. A domain must always have a range. So in a function, a domain must always have a range, and this range must be unique. I'm repeating that. In a function, a domain has a range, and each domain has a unique range. So I'll explain more when I look at how to identify these functions. So knowing that a function is a relation, and a relation can be represented by mapping, like in this case, this is mapping, okay? A relation can be represented by mapping. It can be represented by a graph, okay? It can be represented by a graph, and it can also be represented by an equation, like the one I've already stated, which is this one here. So since a function is a relation, and a relation can be shown by mapping, graph, or equation, and even sets, okay? A relation can also be shown using the set. Now, since this function is a relation, and a relation can be shown using those things, that simply means that a function can also be shown by mapping, by graph, by equation, and by sets. That's why it is very, very important for each one of you to know how to identify a function when it is shown using mapping, when it is shown using a graph, when it is shown using a set, and when it is also shown using the equation. But in most cases, you will be asked to identify a function when it is represented using a set, a graph, or a mapping. So I'm going to go in detail on how to identify a function using the mapping, the set, and also the graph. And note that I need to emphasize on this. Note, remember, as I was explaining, I stated that a function is a subset of of a relation. A function is a subset of a relation. So if we borrow the knowledge from sets, this simply means that not all relations are a function. Not all relations are function. Not all relations are functions, but all functions are relations. I'm repeating that. This is very important when it comes to identifying the functions. One, you need to understand that all the functions are relation, but not all the relations are what? A function. Not all relations are what? Are functions. So let's quickly look at examples and then we'll understand better, because in most cases this part you'll be asked in terms of questions. So let me quickly look at examples. So my first example is let x be equal to, let's say we have open brackets 1 2 3 4. Let x be equal to 1 2 3 4 close brackets, and y be equal to, let's say we have open brackets, let's say we have 11 12 13 14, and then we can say and or such that x is the domain, such that x is the domain and y is the range. Y is the range. Then our question is states whether the following is a function or not. State whether the following is a function or not. So I'll start with A. So I'm going to give a lot of examples on this one, so please make sure that you follow how the mapping is working. So I'll start with this one. So I have this as my x, and my x is having 1 2 3 4, and then I'll get my y, which is this side, and I'm going to put the 11 12 13 14, and this is my y. Remember, my x is the domain and my y is the what? Is the range. So if this mapping was mapped in this way, let's say this guy is going there, this guy, let's say, is going there, this one goes on that one, and then that one is also going there, and this is a function called f of x. So I don't have to put f of x because I don't know if it's a function or not. So in this case, I've been asked to state whether this is a function or not a function. So according to the definition, I said a domain of a function must have a what? A unique range, and every member of the domain or the input must have the what? The range or the output. So guys, If you look at this mapping, do you think this is a function or not a function? Anyone to try? Do you think this is a function or not a function? Are people around? Is this a function or not a function? Yes, Catherine. Sorry, I can't get you. Catherine, is it a function or not a function? I'm sure Catherine doesn't know how to unmute herself. Anyone else? Just unmute yourself and state if it's a function or not. What's the answer? Is it a function or not a? Okay, it's a function, correct. So in this case, this is a function, this is a function, this is a function, because this is a function, because every member of the domain has the range. Every member of the domain has the range. So this is just a function. Okay, I hope there is no question on this particular question. Let me move on and look at B. So for B, I'm using the same information. So this is my X and this is my Y. There I have 1, 2, 3, 4. Then there I have 11, 12, 13, 14. And in this case, what's happening is like this. This one has been mapped to 14. This 3 has been mapped to 11, and 4 has been mapped to what? To 12. So guys, is this a function or not a function? Is this a function or not a function? Anyone to try?
It's not a function.
Correct. So this is not a function. So this is not a function. The reason why it is not a function, because one member in X or one element in X has no member in what? In Y. So F, we can call it as F is not a function. F is not a function because an element in the domain X has no image or relation with a member in Y, The reason why, okay, if you observe at my statement, I'm saying an element in X in the domain is not having a relation with a member in what? In Y. I'm not saying an element in Y. Yes, we are having 13 which doesn't have a relation, but we are not giving this 13 as a reason. Can someone tell me, why am I not saying an element in Y has no member? Instead, I'm saying an element in X, he has no member. Why am I saying so? Can someone give it a try? Why have I said so?
You say something like you not every
Okay, nice try. Nice try. Anyone else? Anyone else? You can give it a try. Okay. The reason why I've said an element in the domain X has no relation with a member in Y is that the range depends on the what? The range depends on the domain. The range depends on the what? On the domain. This means that a function depends on the what? On the domain. This means that a function, okay, this means that a function also depends on the domain. Depends on the domain. I'm putting this emphasis because in the test and the exam they will tell you to identify and to give a what? A reason. So if you look at my reason is saying it is not a function because an element in the domain X has no relation with a member in Y. I'm using the domain because a function depends on the domain. It's more like in real life. We cannot exist if God did not create our parents. So in short, our parents biologically, they are our domain, okay? Mathematically, they are our domain and we are the range. That's why they are our genetic material is something that we inherited from them. In short, what I'm saying is that our appearance, our looks, our character depends or depended on what our parent carried genetically. So if them were not there, we as children would have not existed. This same applies to a function. A function cannot exist if there is no domain. A range, who is the output, us, we cannot exist if the domain, our parent, were not there. Okay, so I hope that is clear. That is clear. Okay, let's quickly look at the other example. Let's quickly look at the other example, which is C. So in C, I'm having the same information. In C, I'm having the same information. So if you look carefully, these things are very easy if you follow them up. So you have X, Y, there you have 1, 2, 3, 4. There you have 11, 12, 13, and what? And 14. So in this case, what we are going to do is this. This one will go that way. Okay? And then what we are going to have again is that this one will go that way. This one will also map on what? 13. And then 3 will map on what? On 4. So my question is this a function or not a function? Can someone give it a try? Is this a function or not a function? Yes, I've seen Frederick. Yes, Frederick, what's your answer? It is a function, correct. So this is a function. This is a function. Why is it a function? Why is it a function? Anyone to give us a reason why this is a function? Can someone give us a reason? Why do you think this is a function? Yes, now Frederick again. Okay, yes, Frederick. Why is it a function?
Because every member is domain.
Correct. So okay, so because every member of X or the domain has a relation with a member in Y or range. Simple. This is simple and straightforward. So this is how easily you can identify if it's a function or not a function. Okay, this is how easy you can easily say if it's a function or not a function. D. So for D, let's say we have something like that one there and the other one there, of which as usual this is X, this is Y, and then in this case we have 1, 2, 3, 4. Then there we have 11, 12, 13 and what? 14. So here what we are now going to do, this is how our mapping will look like. So this one is going there, this one is also going there, this one is also going there, and this one is also going there. So let's quickly look at this one. Do you think this is a function or not a function? Is this a function or not a function? Can someone give it a try? Is this a function or not a function? Yes, Florence?
It is a function.
Why?
Because every member of X has a relation with a member in Y.
Correct. Because every member in X, because every member in X has a relation with a member in Y, with a member in y. Okay, good. Now, ladies and gentlemen, if you look at what we have discussed, there is one important point which I raised. And this important point which I raised was that a function can be shown using the what? Using the graph, and also using the what? The sets. So let me quickly look at the sets notation of functions. So for this part, I'll write identifying functions, shown using sets interval notation. So let's quickly look at how you can identify if a given relation is a function or not a function when it is shown in what? Set interval notation. So you guys, if you observe or if you have been following my classes, when we were dealing with sets, I said sets, they give the basis of everything that we are going to be discussing. And one of them is what? Is functions. Okay? One of them is what? Is functions. So look guys, in a set interval notation, please follow me. I'm slow because I want you to understand. This is where mathematics starts from. I know you enjoyed sets, but this is where mathematics starts from. We are going to be going in detail bit by bit, so I expect you guys to follow. So in set interval notation, in set interval notation of a function, the function f of x is equal to let's say, open brackets, you have a comma b, close brackets. Follow me well. In this case, this is what it means. This A stands for what? For domain. This A stands for domain. And this B stands for what? For range. The B stands for what? For range. A stands for domain. B stands for range. Okay? This is the first principle you need to understand. The first number in an interval notation, the first element, it is the what? The domain. And the one which follows or which is after the comma is what? The range. This is the input. That is the what? the output in set builder, in set notation, when you are dealing with what? With functions. Now, with that being said, this leads me to a state where now I have to teach you on how to identify the domain and how to identify the what? The range. So this is one of the questions which you shall be asked in the exam. Let me quickly look at the example. I will make a separate revision class for this particular part, but for now this is a lecture class. As usual, a lecture class is mostly long and you learn a lot of things. So states the domain and range of the following relation or function, of the following relation or function. So the first one is A. Let's say you have open brackets, that one, say you have 1, 2, then comma, you have 2, 5, and then you have let's say 3, 7, and then you have cross brackets. If you look at this and the question is state the what? State the domain and what? And range. So this is a set which you have been given. So you're going to say solution. You're going to say solution. So this is very easy for you to state. You're going to say domain. Okay? You're going to write domain is equal to, you look for members which are domains. So from that brief explanation I gave, do you have anyone who can try to give us the domain of this particular function? Anyone to give it a try? Yes, Mwemba.
1,2,3.
Correct. 1,2, what? 3. Simple. Very simple. When you are looking for the domain in this particular, you just go there. The first numbers or the first members, they are your what? They are your domain. Okay. With that being stated, let me quickly look at the range. Can someone give us the range in this particular case? Florence, what's your range?
2,5.
Okay.
2,5,7.
7. Chap. Easy. Nothing to worry about. When you are looking for the range, you just go the second image, the second number. Guys, even if you fail to get that A+, then I don't know. Because these are the same concept you'll be taught and these are the same concept you're going to be examined on. The only thing that will be there, they will be spiced up. And that is why now we are going to have a quiz to see how you can analyze. Okay, so with this being given, let me quickly move on and look at example 2. Should be example 2. I don't know if it's example 2 or example 3. I don't know. So state whether the following relations, whether the following relations are functions, or not, are functions or not. So the first one will be, let's say you have